Hi students, let us go with the half-life period of a radioactive substance. Okay, in the name itself, half-life is what? Half of the life. That means if it is 10, half-life is 5. Like that, half-life. Okay, that is the meaning of the half-life. We'll come to the definition first. Half-life means what? The time taken to disintegrate half of its quantity. Okay, what is half-life? It is the time taken to disintegrate half of its quantity is called as half-life. Right? So, here in the definition it is given the half-life period of a radioactive substance is defined as the time in which one half of the radioactive substance is disintegrated. Okay, so let us consider first before disintegration the number of atoms present is n naught. Okay, number of atoms present at time t is equal to 0. Very starting, no? So time t is equal to 0 is n naught. Okay, so number of atoms present is equal to n naught. Time t is equal to at that time which is 0 seconds. Is it not? Time t is equal to 0. And yeah, we know that half-life is what? The time taken to disintegrate half of its quantity. That means what? After half-life, our number of atoms n should be equal to n naught by 2. Is it not? N should be equal to n naught by 2. So now let us consider that. And at that time, the time taken to disintegrate half of its quantity is half-life, no? So for the half-life, we are denoting the half-life as t is equal to, or the t is equal to t half, which we can say that as a half-life. Okay, so now we are having n is equal to n naught by 2 at the half-life period. Okay, and what t is equal to t half. Okay, and we know the formula that n is equal to n naught e power minus lambda t. Okay, we know that, right? N is equal to n naught e power minus lambda t. So substitute the values of n and t here in this equation. Okay, substituting the values of n and t. Okay, substituting the values of n and t, what we get in the place of n, we are getting n naught by 2, which is equal to n naught e power minus lambda t is t half. Okay, now n naught gets cancelled. What we get is 1 by 2 is equal to e power minus lambda t 1 by 2. Okay, when we are doing the derivations like this, we have to remember always what we want to derive. Okay, we want to derive the half-life time, no, that is t1 by 2. So we want the formula for t1 by 2. So for that, what I am doing is, we can write like this, no, half is equal to 1 by e power lambda t1 by 2, because here it is minus. Okay, so what we get now? E power lambda t1 by 2, which is equal to 2. Okay, right. Now lambda t1 by 2 is equal to what we get? Log 2. Okay, so remember, we are doing the derivation, we are deriving this for t1 by 2. Right, now t1 by 2 can be written as log 2 base e by lambda. Okay, so log 2 can be written as, log 2 value is 0.6931 by lambda. Okay, therefore what we get, the half-life t1 1 by 2, which is equal to 0.6931 by lambda is our half-life. Okay, na? Right. So, half-life is what? The time taken to disintegrate half of its quantity. So, now I will tell you one example. For example, we are having 100 number of atoms. N is equal to 100. Okay, now we are having 100 number of atoms. After some time t, what happens? N or N naught, the initial number of atoms is equal to 100. After some time t, N is equal to N naught by 2, that is we can say 50. Okay, and after some time, we'll get this as 25. After some time, this as 12.5. Like this, what happens? Number of atoms is 100, means the time taken to disintegrate half of its quantity, means the time taken to disintegrate 50 atoms. Okay, that we call that as a half-life. Okay, so right now here N is the number of atoms present at any instant of time. N naught is number of atoms present at the initial time. Okay, right. And we know lambda is a decay constant, right? Lambda is the decay constant. So what we get, substituting the values of N and T in this formula, N is equal to N naught e power minus lambda T, we'll get the half-life period T1 by 2 is equal to 0.6931 by lambda, where T half is the half-life period and lambda is the decay constant. This we call that as half-life period of a substance.